Every time you send a message, open a website, or watch a video, data travels across the world in just seconds. But have you ever wondered how that data actually reaches the right destination? The answer lies in something called the TCP/IP model. Imagine you want to send a large parcel to someone far away. Instead of sending it as one big package, you break it into smaller pieces, send them through different routes, and then reassemble them perfectly at the destination. That is exactly how the internet works. The TCP/IP model is a layered networking framework that explains how data is transmitted between devices. It ensures reliable and efficient communication using standardized protocols. It consists of four layers: application layer, transport layer, internet layer, and network access layer. This model was standardized by RFC 1122 and forms the core foundation of the modern internet. And in this video, we are starting a complete playlist on computer networking where I will explain each layer of the TCP/IP model in detail in upcoming videos. At the top, we have the application layer, which is closest to the user. This is where applications like web browsers, email clients, and file sharing tools interact with the network. It acts as a bridge between user software and the lower layers. Protocols like HTTP, FTP, SMTP, and DNS operates here. When you type a website like google.com, the DNS protocol first translates that name into an IP address. Then HTTP or HTTPS is used to request and load the web page. This layer can also provide encryption for secure communication such as HTTPS, which keeps your data safe from attackers. Next is the transport layer. It is responsible for delivering data reliably and efficiently. It breaks large messages into smaller segments and ensures they are properly reassembled at the destination. Think of it like sending a long book in multiple parcels. Each parcel has a number so it can be arranged correctly when received. This layer ensures that no part of the message is missing or duplicated. This layer uses two main protocols, TCP and UDP. TCP is reliable. It checks for error, resends lost data, and ensures everything arrives in the correct order. This is used in applications like web browsing, file downloads, and emails where accuracy is very important. UDP, on the other hand, is faster but does not guarantee delivery or order. It is used in applications like video streaming, online gaming, and voice call, where speed matters more than perfection. The transport layer also uses port number, so multiple applications can communicate at the same time. For an example, your browser and a video call app both use the internet simultaneously without interfering with each other. If you want to know more about TCP and UDP, you can watch my previous video on TCP versus UDP. Now comes the internet layer, which is responsible for addressing and routing. Each packet is assigned an IP address to identify the source and destination. An IP address works like home address for a device on the internet. This layer determines the best path for data to travel across networks. Data doesn't always take a single fixed route. It can travel through multiple routes dynamically depending on the network conditions. It also handles fragmentation and reassembly of the packets. Protocols like IP, ICMP, and ARP are used here. For an example, ICMP is used in tools like ping to check network connectivity. Finally, we have the network access layer, also known as link layer. This layer is responsible for physically transmitting data over the network. It converts packets into frame, sends them through cables or wireless signals, and detects error during transmission. This is where technologies like Ethernet and Wi-Fi operate. It uses MAC address to identify devices within the same network. Unlike IP addresses, MAC addresses are permanent and assigned to hardware devices. Let's now understand how data is sent step by step. When sending data, the process starts at the application layer where the data is created. It then moves to the transport layer where it is broken into segments and assigned port numbers. Next, the internet layer adds IP address to form packets. Finally, The network access layer converts them into frames and sends them over the network. This process is called encapsulation, where each layer adds its own information. At the destination, the process is reversed. The network access layer receives the frame. The internet layer extracts packets and checks the IP address. The transport layer reassembles the segments and ensures accuracy. Finally, the application layer delivers the data to the user. This reverse process is called decapsulation. You might have heard of the OSI model, which has 7 layers. However, TCP/IP is more widely used because it is simpler with only 4 layers. The OSI model is mainly used for teaching and understanding networking concept. TCP/IP, on the other hand, is based on the real protocols and is used in actual networks. It is flexible, robust, and powers the entire internet today. So, in summary, the TCP/IP models break data into smaller parts, routes it across networks, reassembles it at the destination, and delivers it to the user. Understanding this model is the foundation of networking and network security. In the next videos, we will dive deeper into each layer with real-world examples and practical demonstration. If you find this helpful, don't forget to like, share, and subscribe to the Gaurav's Tech for more videos.